NASA is a step closer to getting the first pictures from the James Webb Space Telescope. The spacecraft will seek out faint heat signals from the early universe, but first it has to block out the sun's heat and light with a massive shield. The process of deploying that critical device started Friday. The $10 billion observatory lifted off from Kourou in French Guiana early Christmas morning. The James Webb Space Telescope is NASA's largest and most expensive scientific probe ever sent into space. Once it's fully operational, it will replace the 31-year-old Hubble Space Telescope as the world's premier space observatory. For more on this, we want to bring in CBS News senior space analyst Bill Harwood. Bill, great to see you as always. I'm obsessed with this story. Now, NASA told us before launch it would take 2 weeks to get its sunshade and mirrors deployed. We're now about halfway through that process. How is that all going?
Well, first of all, Happy New Year to all of you up there in TV land. It's going great. They've been very successful so far in the deployment. As you know, getting this sunshade out, it's the size of a tennis court when fully deployed, is a major challenge, and it's where a lot of the risk was with this mission. There were 107 membrane release devices. All of them had to work perfectly to get all 5 layers pulled out from their folded configuration into that iconic kite-like shape that we're familiar with now. The next step is to pull it taut. In other words, tighten up each one of those layers so they lift and separate and there's a gap between each one. That's what lets the heat escape out to the side. That's a critical procedure. They were going to start that yesterday, but they decided to give the team a day off. It was supposed to start today. We haven't yet heard if they did in fact start that or if that might slip in the next week. But so far, so good. We're all going to be on the edges of our seats, though, when they do this tensioning process. It's very critical. It's a very fragile shield, and it's got to go perfectly for Webb to do its job.
Everything is so fascinating and intricate. Now, there isn't any visual reference to see the telescope in action. How are scientists determining its movement?
You know, they thought about putting cameras on this. We're all so familiar with those from rocket cams and the like. But they decided it added a layer of complexity to an already complex program. The lighting is terrible where they are. They're really headed out into deep space. And so what they're relying on is telemetry. They have sensors all over the spacecraft. They know exactly how fast the motors are turning, how much current they're drawing. They can tell, like, for example, if a motor starts working a little harder, they know a cable's not moving freely, that kind of thing. So they've got really good insight, multiple ways of checking the operation of each component. And so far, that's working pretty good. They did delay extending these booms on the sunshade because they wanted to make absolutely sure that these release mechanisms had all done their job. It took a little while extra to do that, but they finally got clearance and pulled them out. So they can certainly check on it. Like you, I wish there were cameras up there, but it was not to be for this one.
Man, I wish we could see those cameras. Well, what is the next phase of this mission, Bill?
Well, they've got to tighten up the sun shield. That's a 2-day procedure. It may start today. It may end up being early next week. That's absolutely critical. If they don't get the 5 layers of that shield to pull up and separate so the heat can work its way out, they can't achieve these super cold temperatures that are required to detect that faint infrared radiation from near the Big Bang itself. So that's critical. Now, once the sun shield gets out, and this will happen next week as well, they're going to deploy the mirrors on the telescope. There's a secondary mirror that goes up in front of the big primary, and the primary itself was folded up for launch to fit inside the rocket. There are 6 of 18 segments that now have to fold out, so you end up with this 21-foot wide mirror that they require. So a lot of action coming up here next week, and again, we're all going to be on the edges of our seats.
21-foot long mirror. Wow. So how long will it take for the telescope to actually transmit images from space once it is up and running?
You know, it's really interesting, Elise. The mirror itself is made up of 18 hexagonal segments. They have to individually line up each segment. Each one of those segments has motors on the back. They can tilt and tip. They can even change the shape of the mirror by pushing in or pulling out. They have to line them all up perfectly to get a razor sharp focus. Then they have to check out and calibrate the science instruments. All told, they expect that to take another 5 months or so after the telescope gets deployed before we see the first science images. So we're going to have to wait for that, but hopefully, if it all works, it'll be worth the wait.
And then once we see these long-awaited photos, what will we learn from these pictures?
Well, you know, that's the $10 billion question, if you will. We don't know. You know, nobody's ever tried this before. They're looking back to the very dawn of the universe. They hope to see the light from the first stars and galaxies to form in the aftermath of the Big Bang itself 13.8 billion years ago. If they can do that, they hope to learn how did the galaxies first form, how do they evolve, how do stars form and evolve. They hope to find out more about where do the supermassive black holes come from that we see today at the cores of just about every major galaxy. The list is almost endless, what they hope to find, but of course, you can't predict the unknown. We don't know what it's going to see yet. That's why they're launching it. So I think we're going to have to just sit by and stay tuned for 6 months and hope for the best.
Right, that $10 billion better be worth it. Now, I've known about the Hubble Space Telescope practically my whole life. What will happen to that, Bill?
Well, you know, we always talk about Webb replacing Hubble, but that's down the road. Hubble is working really well right now. It's, as you said, it's more than 31 years it's been in space. It's all going to come down to how long its components work, but the instruments on board are still working. The gyroscopes that have to keep it stable, it started out with 6. They're down to 3, but those 3 are working just fine. They hope to get several more years out of it, and that's one of the exciting things about the Webb launch. You know, Hubble is designed to look in the visible light realm, what your eyes see and my eyes see. Webb is designed for infrared light. They hope to be able to study targets with both telescopes at the same time and get this multispectral view, which should really be quite significant. So, you know, knock on wood, but hopefully Webb will be around for many more years.
All very exciting. Bill Harwood, thank you as always.